The third type of collision occurs when two oceanic plates, two thin crusts of basalt, meet in a collision zone. As this map of the tectonic plates indicates, we have several such points at which oceanic plates collide. In particular, we will quickly review three such areas. One, the line between the west coast of Indonesia and the Indian Plate. Secondly, the ring of fire or zone around the edge of the Pacific Plate, such as this area that runs east of Japan. And thirdly, a collision in a relatively small plate between the large North American plate and the Caribbean plate, here running through what is now Cuba and Hispaniola. This illustration shows what occurs when two oceanic plates collide. As indicated here, the advance of the plate on the right, from right to left, causes the subduction of a thin basaltic oceanic plate under its adjacent neighbor. When that occurs, again, we have earthquakes caused by the sudden jerky advance of these plates. Secondly, the melting of the subducted basalt into a magma and its formation of volcanoes. You will also note on this slide that this collision creates a trench between the two plates lying to one side of the volcanic islands. As we look at this map of volcanoes and earthquakes, we're going to focus, as I said, on three zones. The first of these lies to the west coast of Indonesia, between the Indian Plate and the Pacific Plate. And here we had in 2004 the collision between these two plates and a major earthquake offshore. When the earthquake occurs, the bottom of the ocean on one side drops significantly with respect to its neighbor on the other side, because the advancing plate is subducting underneath the opposite plate, and it causes a depression on the ocean floor. When the ocean floor drops, the water level above it drops, and this forms a major tidal wave or tsunami. When this occurred off the coast of Indonesia in 2004, the tsunami or tidal wave set off by this earthquake was so large that it traveled all the way across the Indian Ocean to the east coast of Africa, and was the source of over 200,000 deaths throughout Asia and Africa. A second oceanic collision occurred between the North American plate and the Caribbean plate in 2010 in the Great Haitian Earthquake of 2010. Again, the collision between two oceanic plates caused the snapping of these plates and this very destructive earthquake on the border between the Caribbean and North American plates. And finally, in 2011, we had another tsunami that occurred off the east coast of Japan that caused considerable destruction simply by the great tidal wave, but more notably, the tidal wave submerged the Fukushima Daiichi nuclear plant, causing the cooling generators in that plant to shut down, the nuclear rods to overheat, and we had both a meltdown of the nuclear rods in the nuclear plant and what are called hydrogen explosions, spewing nuclear radioactive materials broadly throughout the region, creating one of the most serious disasters in Japan's history. And finally, an example of the collision between these plates is in the formation of the Pacific volcanic islands. Here is a photo of Tonga, a Pacific island at the time of its volcanic eruption. And we are then reminded that after the eruptions subside, the Pacific Ocean has been left with these tranquil and idyllic volcanic islands as pictured here.